Hello everyone. So today's topic is limits and derivatives. So suppose a body is dropped from a tower and it covers a distance of y is equal to half gt square, where g is acceleration due to gravity and t is time taken by a body to cover a distance of y. So therefore, on the basis of value of time, we have tabulated the values up to time is equal to 4 seconds. So at 0, 1, 1.5, 1.8, so this is time and this is distance covered. So at 0, distance is 0, at time is equal to 1, distance is 4.9, this is in meters and this is in seconds. And next at 1.5 seconds, the distance covered is 11.025 meter. At 1.8 seconds, 15.87 meter. 1.9 seconds, 17.7 meter. 1.95 seconds, 18.6 meter. 2 seconds, 19.6 meter. And 2.05 seconds, 20.6 meter. And at 2 point at 3 seconds it is 44 meter. At 4 seconds it is 78.4 meter. So these are the values of distance based on time, which follows the law half gt square. So next is now we have to find the average velocity that is v average is equal to s2 minus s1 divided by t2 minus t1 at t equal to 2 seconds. So let t1 vary and t2 be fixed. T2 equal to 2 seconds be fixed because we need to find velocity at 2 seconds. So now we will start with t1 equal to 0 seconds, that is, and t2 equal to 2, which is fixed. Therefore we have v average is equal to s2 19.6 minus 0 divided by 2 minus 0 is equal to 9.8 meter per second. Similarly, when t1 is equal to 1, v average is equal to 14.7 meter per second, where t2 is 2. So therefore As t1 approaches t2 seconds, the average velocity increases gradually. That is, when t2 minus t1 decreases, v average increases. So if we kept on approaching t2 equal to 2 second, if we keep on approaching t2 equal to 2 seconds, we see that v average approaches some constant value of 19.5 meter per second. That is, if t1 is equal to 1.95 seconds, or t1 is 1.96 seconds dash dash dash, and t1 is equal to 1.99 seconds, so all these values are approaching towards t2 equal to 2 seconds. So if we find t2 minus t1 for all the values of t1, 1.95 to 1.99, t2 minus t1 becomes very small. So hence, as t2 minus t1 approaches 0, not equal to 0, we get v average almost constant. So from here we get the rate of change of distance at any instant of time. So we can define we get the rate of change of distance at any instant of time. Instant means like we have taken t2 equal to 2 seconds. This is also known as derivative. This is also known as derivative. So mathematically, v average is equal to s2 minus s1 divided by t2 minus t1, or we can say s2 minus s1 is equal to delta s, and t2 minus t1 is equal to delta t. So when t2 minus t1 or delta t approaches, this is a symbol of approaches 0, then we get derivative of distance at any instant of time. That is, v average when limit delta t tends to 0 or approaches to 0, and delta s by delta t, we get ds by dt. Where ds by dt is equal to derivative of a derivative of s with respect to time, and delta s by delta t is not equal to ds by dt. Similarly, if we take any point t1 greater than t2 greater than t2 equal to 2 seconds, that is t1 is equal to 2.001 or t 2.008 or 2.01 or 2.07. So all these values are greater than 2 and closer to 2. These values are greater than 2 and approaching towards 2. Approaching towards 2. So again, delta t approaches 0. Hence, we get a derivative of distance with time. Hence, we get a derivative of a distance with respect to time. So graphically, so this is a plot, this is s and this is t, and we have a curve. So this is let point, this is point c, and this is point d, a, and this is point b. So a point is at t1 and c point is at t2, which is fixed, equal to 2 seconds, and this is point b, which is at time t3. So the plot shows the graph between distance and time. So let t2 is fixed, where we need to find the average velocity, where we need to find average velocity. So let the coordinates of point B be, let the coordinates of point A be t1 comma s1, and coordinates of point B be t3 comma s3, and coordinate of point C be t2 comma s2. So from the definition of a slope, that is, we have A and C and B, where coordinates of A are t1 comma s1, and this is t2 comma s2, and this is t3 comma s3. So from slope definition, slope is equal to y2 minus y1 divided by x2 minus x1. So slope of AC is equal to MAC is equal to S2 minus S1 divided by T2 minus T1. Similarly, slope of BC is equal to S3 minus S2 and T3 minus T2. So from the graph ST, so this is point A and this is point C and this is point B. So as this is point T1, So as point A approaches TC, that is from left hand side, from left side, from left, such that T2 minus T1 is approaches 0. So we get left hand limit. Left hand limit. Similarly, if T3, this is T3, this approaches point C from right, approaches, that is point B approaches point C from right. Then we get T3 minus T2 approaches 0, and we get right hand limit. So mathematically we can write that limit delta t tends to 0, slope of AC is equal to limit delta t tends to 0, slope of MPC. So here left hand limit and is equal to right hand limit. Left hand limit is equal to right hand limit. Therefore we can say the limit exists. Therefore we can say limit exists. So next is, what is tangent? So if we keep on decreasing the difference between time intervals, if we keep on decreasing the time difference that is T2 minus T1 approaches 0, then slope between 2 points, slope between 2 point approaches to the tangent to the curve, to the tangent to the curve at point at some point T2. So graphically this is S distance and this is time. So we have this curve and this is point C. So this is fixed point D2 where we need to find the velocity, and suppose this is point A where time is T1 and this is a slope. So this is theta. So if A is keep on approaching C, that is this is A1, then we get a slope of A1C like this. Again we have A3, then so this is so A1 is approaching a C point. So after some point of time when the time difference is T2 minus T1 is negligible, then we can say the slope is tangent at C. Slope is tangent at point C. So if generally if slope is delta y by delta x, then slope of tangent is equal to limit delta x tends to 0, where this is x and this difference is delta x or delta t. So when this approaches 0, we get a tangent at the point. So delta y by delta x is equal to dy by dx, where dy by dx is equal to slope of tangent, and from trigonometry slope is equal to tan theta. Therefore slope of tangent is equal to dy by dx equal to tan theta, where this is dy delta y and this is delta x, where delta y by delta x is not equal to dy by dx. So therefore slope of tangent is also known as derivative of y with respect to x. The slope of tangent is also known as derivative of y with respect to x. So therefore with the concept of slope, with the concept of slope, we get two important concepts, that is limit and derivative. Where derivative is a consequence of limit. Derivative is a consequence of a limit. And so this is delta notation. This means delta, which means very large, and d is, which is used in derivative, is known as del, which means infinitesimally small. So this is not visible with naked eye, not visible with naked eye. So as therefore from the above example, if t2 minus t1 is very large when compared to limit delta t tends to 0, that is delta t, this is delta t and this is very large, and this whole is dt. So suppose we have a example, it's fx is equal to x square. So in this if we take a value of very close to 0, if we take so here we need to find a limit of x tends to 0 of f of x. So by limit we mean we will take a value of x close to 0 but where x is not equal to 0. So the value of fx will move towards 0 as x approaches 0. So we say limit x tends to 0 f of x is equal to 0. So limit does not mean value of fx at x equal to 0. It means value of x near x equal to 0. So in general, as x approaches some point a, and from this f of x approaches some point L, then L is called the limit of a function f of x. L is called a limit of a function f of x, that is limit x tends to a, f of x is equal to L. So we have another example. So g of x is equal to mod of x. So by piecewise notation, we have positive x when x is greater than 0 and negative x when x is less than 0. So if we take left hand limit, that is, this is a graph of g of x. So we need to find limit at x equal to 0. So left hand limit will be when x approaches 0 from left hand side. So this is left hand limit, that is limit x tends to 0 negative mod of x is equal to 0. Similarly, when x approaches 0 from right, we get right hand limit, that is limit x tends to 0 positive mod of x is equal to 0. So from here, right hand limit is equal to left hand limit. Therefore, we say limit exists. However, the value of function g of x is not defined at x equal to 0, because x can take only either negative value or a positive value. X can take only either negative or positive value. So if we take x equal to minus 0.0001 and x equal to plus 0.0001, then g of x, that is mod of minus 0.001, this approaches 0, and also plus 0.00, this also approaches 0. So therefore we can say left hand limit is equal to right hand limit, but g of x mod of x is not equal to 0 at x equal to 0. So next example is, let h of x is equal to x square minus 4 divided by x minus 2, where x minus 2 is not equal to 0. So from the above equation we can see at x equal to 2, h of x is not defined. But as x approaches 2, that is, if we take any value of x near 2, that is, suppose let's say x is equal to 1.99, so we see that hx will approach value of 4. So we say limit exists near x equal to 2. We say limit exists at near x equal to 2, near x equal to 2, but function is not defined at x equal to 2. That is, if h of x is equal to x square minus 4, x minus 2, and we have h of x equal to x square minus 4, x minus 2. So if let's say here x is 1.99 and here if you put value of x equal to 2, so from here h of x is equal to 1.99 square minus 4, 1.99 minus 2. So we get from here 3.99, and if we put x equal to 0, we get 0 minus 4, x equal to, if we put x equal to 2, we get 2 square minus 4 divided by 2 minus 2. So we get 4 minus 4 and 2 minus 2, which is equal to 0 by 0. So at x equal to 2, the function is not defined, but value of x near 2, that is x equal to 1.99, we get h of x is approaching 4. So therefore we can say limit exists near x, but function is not defined at x. Therefore the value which the function should assume at a given point x equal to a did not really depend on how is x tending to a, did not really depend on how is x tending to a. So there are essentially two ways we could approach a. So there are essentially two ways where x could approach any value x equal to a, either from left or from right, either from left or from right. So as we have seen from the example of velocity, where x is equal to 1.99 from, where t is equal to 1.99 from left, and t is equal to 2.01 from right. So there we get two limits, right hand limit. So this is right hand limit and this is left hand limit. So what is right hand limit? Right and left hand limit. So right hand limit of a function f of x, right hand limit of a function f of x is that value of f of x which is dictated by the values of x which is dictated by the value of f of x when x tends to x equal to a from right. So we say, therefore we say limit x tends to a positive. Positive means that x is approaching, so here positive means x is approaching from right. F of x is the expected value of f of x at x equal to a. Given the value of f near x value of f of x near x equal to a to the right of a to the right of a is called right hand limit of f of x at a. So suppose this is a curve and this is x-axis, this is y-axis, this is point A. So if we take any point near A, that is, suppose this is a plus h. So we say at x equal to a plus h limit exists. So that is limit x tends to a positive f of x should be equal to f of a plus h, which is right hand limit. Right hand limit. So next is left hand limit. So we say where h is very small, h is very small. So we say limit x tends to a negative. So negative means x is approaching a from left. So limit x tends to a negative f of x is the expected value of function f at x equal to a given the values f near x to the left of x equal to a. This value is called left hand limit. This value is called left hand limit. That is, if this is a graph, this is x and this is y and this is point A. So suppose we take point A minus h in the left side. So we say limit x tends to a minus f of x is equal to value of a function of at x equal to a minus h. So this is a left hand limit. For example, f of x is equal to 1 2. So when x is less than equal to 0, value of fx is 1. When x is greater than 0, value of fx is 2. So graphically this is 0. When x is greater than 0, we have a hole, and this is, and when x is less than 0, we have So this is 0 comma 2 and this is 0 comma 1. So from here we can see as x approaches from left, this is left and this is right. So limit x tends to 0 negative, f of x is equal to 1. So value of function when x is approaching 0 from left hand side is equal to 1, and value of limit when x equal to 0 positive, that is when x is approaching from positive side to 0, then value of fx is 2. So here left hand limit is not equal to right hand limit. So this is left, this is right. So when does limit exist? So when limit x tends to a negative, that is x is approaching from left hand side because there is a negative sign, is equal to limit x tends to a positive. Positive means x is approaching from right hand side, f of x, then we say limit exists. Then we say limit exists. However, value of f of x at x equal to a is different. So in general, at a given point, the value of the function and its limit may be different. Even when both the limits are defined. Even when both the limits are defined. For example, in previous example where g of x is equal to mod x, so as x approaches 0 from left hand side and x approaches 0 from right hand side, we say limit exists. Limit exists at x tends to 0. But at x equal to 0, function is not defined. 0 is not defined, but limit exists. So next is algebra of limits. So algebra of limit is a limiting process. Limiting process conforms to addition, subtraction, multiplication, and division. As long as the limits, the limits and the function under consideration are well defined. So first is addition operation, that is limit x tends to a, f of x plus g of x is equal to limit x tends to a f of x plus limit x tends to a g of x, and the second is limit x tends to a and f of x minus g of x is equal to limit x tends to a f of x minus limit x tends to a g of x. Next is a product rule. Limit x tends to a f of x dot g of x is equal to limit x tends to a f of x cross limit x tends to a g of x, where this is multiplication sign. So last is rational function. Limit x tends to a f of x divided by g of x. So here we get limit x tends to a f of x divided by limit x tends to a g of x, where limit x tends to a g of x should not be equal to 0, and this is a scalar multiplication of a function. So limit x tends to a, and this is lambda is a scalar, f of x is equal to limit, so we take the scalar out and take the limit of a function. So this was about algebra of limits. Next is limit of polynomial and rational function. Limit of polynomial and rational function. First is let f of x is equal to a naught plus a1x plus a2x square plus a3x cube dash dash an xn. So we say limit at limit when x approaches a, we get limit when x approaches a f of x is equal to a naught plus a1a plus a2a square plus a3a cube and an. So we can say for polynomial function when x approaches a, f of x should be equal to f of a. Second is rational function. So limit x tends to a, g of x divided by h of x is equal to g of x divided by h of x. So g of this is g of a and this is h of a. So what if h of a is 0? H of a is equal to 0. So we have two cases in this. When g of a is not equal to 0 and when g of a is equal to 0. So when g of a is equal to 0, then we say limit x tends to a, g of x divided by h of x is not defined. And when g of a is not equal to 0, so let's suppose say g of x is x minus a to the power n into some function of x, where n is a maximum power of x minus a, maximum power of x minus a in g of x. And let's say h of x is equal to x minus a to the power m and some function of x. So where m is the least power of x minus a in h of x, and n is greater than equal to m. So therefore we can write g of x by h of x is equal to x minus a and g1x and x minus a and m h1x. So which is equal to x minus a to the power n minus m into g1x divided by h1x. So now if we take a limit of a function, the limit of x tends to a f of x g of x by h of x, then we get x minus a n minus m g1x divided by h1x. So now if we apply the limit, then we get a minus a to the power n minus m and g1a divided by h1a, which is equal to 0. So next is a rule of a limit, power rule. That is, if limit x tends to a and x n minus a n divided by x minus a, so we get n a to the power n minus 1. For example, suppose we need to find a limit of a function where x tends to 1 and x 15 minus 1 divided by x 10 minus 1. So first of all, if we compare with this above equation, we have n is equal to 15 and in denominator we have n is equal to 10. So we need to convert in the form of xn minus an divided by x minus a. So multiply numerator and denominator by x minus 1. So we get x minus 15 minus 1 divided by x minus 1 into 1 divided by x divided by x minus 1. So this is of the form xn minus an divided by x minus 1, and this is also of the form xn an minus xn minus 1, where limit x tends to 1. So from here we get n equal to 15 and a is 1, and 15 minus 1 into 1 divided by 10 cross 1 10 minus 1. So therefore we get 15 divided by 10, so 3 by 2. So next is we have a following theorem which says when any function f and any function g be two real valued function, real valued function with same domain, such that f of x is less than equal to g of x for all x in the domain. So we get limit x tends to a f of x is less than equal to limit x tends to a g of x. That is, if we say graphically, this is y and this is x. So this is some function f of x, g of x, and this is some function f of x. So if we take any point x here, so we see f of x is less than g of x. So here f of x is less than This is f of x1 and this is g of x1. So f of x1 is less than g of x1. So as we keep on going along x, we get f of x is less than g of x. So here f of x is, so at some point x equal to a, x tends to x equal to a, we say f of x is equal to g of x. So again after point a, if we have some points f of x, then f of x is less than g of x. So at every x, either left of x equal to a or right of x equal to a, we say f of x is less than g of x. But at x equal to a, f of x is equal to g of x. Next is limit of a trigonometric function. Limit of a trigonometric function. So this was related to trigonometric function. So next is we have sandwich theorem. So if we have three functions f of x, g of x and h of x, and it says that f of x is less than equal to g of x and is less than equal to h of x. So if we say limit x tends to a, f of x is equal to limit x tends to a, h of x is equal to m, then we can say limit of x tends to a, g of x should also be equal to m. That is, if we see on a graph of function, this is h of x and this is g of x and this is f of x. So at every point of x, we have f of x is less than g of x is less than h of x at every point of x. But at x, when x tends to a, we have limits are equal. Similarly, when x is away from a, we have same value of x, that is f of x is less than g of x is less than h of x. So this defines one important inequality, that is cos x is less than sin x divided by x and is less than 1. So this says that when x approaches 0 and cos x, that is equal to cos 0 from the definition of a limit, that is limit x tends to a, f of x should be equal to f of a. So we say the value of f of x near x equal to 0 is 1. Similarly, we have limit when x tends to 0 is equal to 1. This is 1. So we can say limit of x tends to 0 sin x by x equal to 1 by sandwich theorem. By sandwich theorem. So or we can say f of x is equal to cos of x and g of x is equal to sin of x divided by x and h of x is equal to 1. So limit x tends to 0, f of x is equal to limit x tends to 0, h of x equal to 1. So by sandwich theorem, we say limit x tends to 0, that is g of x, or limit x tends to 0 sin x by x should be equal to 1, where x is less than greater than 0 and less than pi by 2. So for all the values of x between 0 and pi by 2, we have f of x is less than equal to g of x is less than equal to h of x. Only when x lies between 0 and pi by 2. So next is what is the limit of a function when x tends to 0? 1 minus cos of x divided by x. So from trigonometric identity, we know 1 minus cos 2x is equal to 2 sine square x. So 1 minus cos x will be 2 sine square x by 2. So uh, so we put 1 minus cos x equal to 2 sine square x by 2 by x. So it follows sine square x by 2 divided by x divided by 2. So now split the terms, sine x by 2 by x by 2 into sine x by 2. So this is the above uh, a limit, that is sine x by x, where limit x tends to 0 is equal to 1. So this value is 1. And if we put by the definition of a limit x equal to 0, so sine 0 will be equal to 0. So 1 cross 0 is equal to 0. Therefore limit x tends to 0, 1 minus cos x divided by x is equal to 0. So this was about limits and slope. So next is derivative. So we have already defined derivative in terms of distance and time. Now we will generalize the term derivative. That is, if we have a graph, this is y and this is x, and we have some curve. This is point P, this is point Q, and at x equal to a is P, and x equal to some point a plus h, we have Q. So this is a chord PQ, chord PQ. So we have this chord PQ. So let's suppose this is delta x, this point be M, and this is delta y, and the angle which the PQ makes with x-axis is theta. So by definition of a slope, by slope definition, that is M is equal to f of a plus h minus this is f of a plus h, and this is f of a minus f of a divided by a plus h minus a. So where a plus h minus a is equal to delta x. So if we rearrange the terms, a get cancelled out, so delta x should be equal to h. So therefore slope is equal to f of a plus h minus f of a divided by h. So by definition of a limit, if we say limit h tends to 0, limit h tends to 0, f of a plus h minus f of a divided by h, we get a derivative of f with respect to a with respect to x. So where we can say derivative of f is denoted by f of dash. So we say that the chord PQ tends to the tangent at point P when point Q approaches point P. So if we say the limit of slope is equal to slope of tangent, and we can say the slope of tangent is equal to derivative of function slope of tangent is equal to derivative of a function is equal to tan theta. So by definition we say suppose f is a real valued function and a is some point in its domain, a is some point in its domain of definition, then we say the derivative of f at x equal to a is limit h tends to 0, f of a plus h minus f of a divided by h, provided limit exists. So this is a definition of a derivative. So this is known as derivative of a function f, and the derivative of f of x is denoted by f dash x. So this is function and this is derivative of f. So next is what is the first principle of derivative? What is the first principle of derivative? So suppose f is any real valued function. So the derivative of a function is defined by, so derivative is defined by derivative is defined by limit h tends to 0 where f of x plus h minus f of x divided by h. So whenever limit exists, the is defined to be the derivative of f at x and is denoted by f dash x. So wherever the limit exists, which is defined to be the derivative of function at x and is denoted by f dash x is, so this definition is this definition of derivative is also called the first principle of derivative. So we can write f dash x is equal to limit h tends to 0 where f of x plus h minus f of x divided by h. So where f dash domain of f dash x is wherever the limit exists, where domain of f dash x is wherever limit exists. So so we have a denotion how to denote the f dash x is denoted by d by dx of f of x, where y is equal to f of x. So we can write f dash x is equal to dy by dx. So we also denote derivative of function as, so f dash x is also denoted by capital D f of x. So this is known as d by dx. So let's take an example. Suppose f of x is 10x. So f dash x will be equal to limit h tends to 0, 10 of, that is f of x plus h. So that is f of x plus h will be equal to, if we replace x by x plus h, and minus f of x divided by h. So this is equal to 10h by h, where h is equal to 10. So this is how we evaluate the derivative of function by first principle. So this is first principle. So next, so by first principle we have, suppose this is f dash x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. So it's not that we can take only f of x plus h, we can take any point that is left x minus h. So like we take the case of limits such as left hand limit and right hand limit. So here we will also take the same approach, that is, this is a graph of f of x, and let suppose this is point A and this is point B and this is point C. So suppose we have at x equal to a, that this is point B is x, and suppose this is point C is x plus h, and point A is x minus h. So by the method of slope, that is MAB is equal to f of x minus f of x minus h divided by x minus h is equal to f of x minus f of x minus h divided by h. Similarly, we can write a slope of BC, that is f of x plus h minus f of x divided by x plus h minus x. So we get f of x plus h minus f of x divided by h. So now if we take a limit of both the slope, limit h tends to 0 m of AB, then we get which is equal to limit h tends to 0 MBC. So this is called a left hand derivative, and this is known as right hand derivative, because in case of left hand derivative, A is approaching B from left hand side. This is left hand derivative, and C from right hand side C is approaching B. So this is right hand derivative. So these both limits are equal to derivative of function with respect to x. So we say derivative exists only if left hand derivative is equal to should be equal to right hand derivative. Then only we can say derivative of function exists So this was similar to the case of the limits, where we define the left hand limit and right hand limit, and if both the limits are equal, then the limit exists. So next is algebra of derivative. So first is derivative of d by dx of f of x plus g of x is equal to d by dx of f of x plus d by dx of g of x. Second is d by dx f of x minus g of x is equal to d by dx f of x minus d by dx g of x. And third is d by dx, this is product of two functions, so we get d by dx f of x into g of x plus f of x into d by dx of g of x. So this is also known as Leibniz rule, and this is very important. And last is quotient rule, d by dx of f of x by g of x is equal to d by dx f of x g of x minus f of x d by dx g of x divided by g of x to the power 2. So next is we have a power rule. So if we have f of x in the form of x to the power n, then we can find derivative of f of x such as n x to the power n minus 1. So this is known as power rule. So this rule is very useful when we have to find the derivative of higher power when where the first principle takes a lot of time. So it is used to find the derivative of higher power where the first principle that is limit h tends to 0 f of x plus h minus f of x divided by h takes a lot of time. So suppose we have example f of x is equal to x to the power 100. So if we need to find a derivative, so we have two methods, first principle and power rule. So by first principle, first principle we get x plus h to the power 100 and x to the power 100, and this is h. So limit h tends to 0. So if we need to find x plus h to the power 100, it will take a lot of time. So we will not use first principle in case of higher power. Uh, so we will use power rule, that is f of x if f of x is x to the power 100. So by power rule f dash x is equal to 100 x 100 minus 1. So we get 100 x to the power 99. So this is derivative of f of x by power rule. So next is, for example, we have f of x is equal to x and x plus 1. So we have two functions. Suppose this is function g of x and this is h of x. So by product rule, by Leibniz rule, we have a derivative is equal to d by dx of gx cross h of x plus d by dx of h of x cross gx. And for finding the derivative we use power rule. So we use power rule and Leibniz rule. In this case, power rule and Leibniz rule. So derivative of g of x should be 1 into h of x plus derivative of h of x should be 1 plus 0 into g of x. So this is 0 because derivative of constant is equal to 0. Therefore we get derivative of f of x is equal to x plus 1 plus x, that is equal to 2x plus 1. Also, in power rule, that is f dash x is equal to n x n minus 1. So where n can take any value, n can take any value, that is n belongs to a real number. So next is derivative of polynomial and trigonometric function. So derivative of polynomial and trigonometric function. So let f of x be any polynomial, that is a naught xn plus a n minus 1 xn minus 1 plus dash 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 a1 x plus a naught. So we say derivative of f of x should be equal to an x. So we will use here power rule in each term, that is n minus 1 x n minus 2 and 0. So we will apply derivative rule to each term and then add the subsequent terms to find the derivative of the whole function. So suppose we have example 600 x 99 minus 55 x 54 plus 1. So here we will first find the derivative of this function. Let's suppose derivative be f1 dash, and this is derivative be f2 dash x, and this is f3 dash x. So final derivative will be equal to f1 dash x plus f2 dash x plus f3 dash x. So which f dash is by power rule will be 600 into 99 x 99 minus 1 plus f2 dash will be equal to minus of 55 cross 54 x 54 minus 1. So this is power rule we have applied to find the derivative. Next is f3 dash. So this is a constant function. Derivative of constant is equal to 0. So we get 600 cross 99 x 98 plus minus 55 cross 54 x 53 plus 0. So derivative of function is given by 600 into 99 x 98 minus 54 into 54 x to the power 53. So this is how to find a derivative of any polynomial function. First divide each term into segments and find derivative of each terms, and then in last add all the derivatives to find the derivative of whole function. Next is derivative of trigonometric function. Derivative of trigonometric function. So we get suppose we have f of x is equal to sine of x. So by first principle, limit h tends to 0, sine of, we replace x by x plus h minus sine of x divided by h. So by trigonometric identity, sine of x x plus h will be equal to sine of x cos of h plus sine of h cos of x. So we replace sine of x by this term. So we get limit h tends to 0, sin x cos h plus sin h cos x minus sine of x divided by h. So we split the term sin x cos h by h plus sin h by h cos x minus sin h divided by h, and limit h tends to 0. So if we rearrange the terms, we get cos h minus 1 divided by h plus sin h divided by h cos x. So from the definition of limit of this function is limit h tends to 0 is 0. So we get sin x cross 0, and from definition of limit sin x, limit of x tends to 0, sin x by x, we have value of 1, and cross cos of x. So limit, so now this is 0 and this is equal to cos of x. Therefore derivative of sin of x is equal to cos of x. Similarly, we can find derivative of other trigonometric function by using first principle of derivative and properties of limits. So this was about limits, slope, and derivative, and properties of derivative, and uh, derivative of polynomial and trigonometric function. Thank you.